Okay, so you will learn to prove two triangles congruent using the HL congruence theorem in this lesson. Right? In the right triangle, the side opposite the right angle is always called the hypotenuse. Right? We've talked about in class this year the Pythagorean theorem, right? We reviewed it when we did distance in the coordinate plane. And we said that in a right triangle, right, there are special names for parts. The two parts that make the right angle are called the legs. And when we think of Pythagorean's theorem, we call them like A and B. So Pythagorean's theorem is A squared plus B squared equals C squared, right? Well, when we say that, the A and B are like the legs. They're the ones that make the right angle. And across from the right angle is called the hypotenuse. So that's where the HL comes from. So what the HL congruence theorem says is this, is if the hypotenuse and a leg, so the hypotenuse, which remember is the longest side, that's the side across from the right angle, and a leg of a right triangle are congruent to the hypotenuse and the leg of another right triangle, and again, this is, they keep saying right triangle, right? It has to be a right triangle, then the triangles are congruent. So what this tells me is this can only be used for right triangles. Now, it's not always used on right triangles. We could have other parts given and not be using this in a right triangle. But if we have a right triangle, this is a tool we could use if we knew a hypotenuse and a leg was congruent. Now, why this works is this. It's actually connected to the side theorem. Because if we knew that a leg in two triangles, so say we knew in these two triangles, these legs were congruent, and we knew the hypotenuses, I guess, I don't know how you say it, are congruent, then we actually could figure out that the third sides would have to be the same length, so these third sides, the other legs, right, because of Pythagorean's theorem, right? So like, for instance, let's say this hypotenuse, or I'm sorry, this leg was 3 and this one was 3 because they're congruent, and say this hypotenuse was 5, and so this one is 5 because they're congruent. And I use Pythagorean's theorem to find out this one. I'd say 3 squared plus b squared equals 5 squared. That would work for both triangles, right? So 3 squared is 9 plus b squared equals 5 squared, which is 25. If we subtract 9 from both sides, that gives us b squared equals 16. And then take the square root. That means these other legs would have to both be 4. So then in effect, we really have side, side, side. But that would be a lot to have to do every single time if we only knew a leg and a hypotenuse, to have to then use Pythagorean's theorem to find the third sides and then show they were equal. So this theorem actually says because this relationship always holds in right triangles, that this has to be the case, okay? That the third sides would have to be the same if this were a right triangle. So we don't use side, side, side. We use HL because that's shorter. It's a shortcut and it's easier than having to find that third side. Okay, does that make sense? So let's test that out in some examples. It says to determine whether you can use HL to prove the triangles are congruent. Explain your reasoning. A lot of times explaining your reasoning just involves us maybe labeling the drawing and stating a theorem that says they are congruent. So in number, a real formal explanation is a proof. They're not asking us to prove something here. So on example A, they tell me that M is the midpoint of AB. And then they give me this drawing, okay? So I really don't even need to know that M is a midpoint. But because they tell me M is the midpoint of AB, I actually can prove these triangles congruent lots of different ways. I'm going to just list all the ways. First of all, right away I can tell that this is a situation where we could use HL because these are the hypotenuse. One to try on your own, okay? So in this pair of triangles, I have these sides marked congruent, so you can see with the matching markings. Right? They've got 3 tick marks here, 3 tick marks here. That's a pair of sides. And let's say you're not noticing they're right triangles, and let's say you started using our old method of labeling, and we do S, S, and then you're like, oh, there's a right angle, and if that's a right angle, then this angle, which is a vertical angle to it, must be a right angle, right? So we know this by vertical angle theorem, okay? And you label that an A, let's say. If you see that, and you see SSA or ASS, when you see the ASS theorem, right, that really means, nope, there's no such thing as that, but there is the HL. Okay? So when you have two right triangles and you see that the order of the parts that is given is an angle and then two sides, or two sides in a row and then the angle, then you know it's the HL. Okay, so, you know, again, so if you're not right thinking ahead of time, hey, you know, these are right triangles, I'm going to instead use H and L to label these, because you're not always using the HL theorem, right? So say you start using the S and the A to label the sides and the angles. Okay, but when you see that one and you know that's not one of our shortcuts, then you know, okay, then it has to be the HL. Okay. All right, so let's designate this one a you try question. So if you are watching this in the video and not live in class, you're going to pause the video now and you're going to give D a try and see if you can use the HL congruence theorem to prove these triangles are congruent. So pause the video now if you're watching the video, and if you're live in class, just put something in the chat for me. Yes or no. Can you use HL or not? So yes, you do have a shared part here. So we have that shared leg that turns out to be a leg, right? And so we've got the hypotenuse and the leg. So again, that whole naming strategy, if we used it here, we'd say, oops, I didn't mean to use two markings here, because then that's what they used on the other one, so maybe mark one. Then I'd say, okay, yep, that's the angle side, so that means it has to be the HL congruence. Okay, so let's take a look at example 1 here, where it says, determine whether you can use the HL to prove the triangles are congruent and explain your reasoning. Well, sometimes they'll give you enough information that you can actually use more than one way. So we're going to kind of explore that on this one and see if there's more than one way. Now look, just looking at the markings that are on the figure already, they mark that these two are congruent, that they're right triangles. I can see they have a little right angle on them. And so if I wanted to use the HL congruence theorem, I would need to know that one of the pairs of legs is congruent. Now, they have a pair of legs that they actually share, right? So I know for sure I could use HL here because they share that leg, and I could use the reflexive property to show that. But also, if I had not used this pair in the middle, I could have used the fact that M was the midpoint of AB, and I could have shown that these were congruent. That still would be HL. But then even if they hadn't given me this pair, let's say they hadn't given me this pair, or I just sort of, you know, ignored it, I didn't see that, and I could, if M was the midpoint, and I knew that they also shared this common side, I even could have used these parts, and this actually would be side angle side. So I could use side angle side, or now again, let's say I didn't even really pay attention that these had two right angles that would be congruent, but they had told me that AM is congruent, or that M is the midpoint, so AM was congruent to MB by the definition of midpoint, right? Then I could, let's see, let me write that down, definition of midpoint. Then I could show that all three pair of parts, of sides, excuse me, are congruent. So I could even use side, side, side. So like I said, side, side, side is always kind of like the basis of why two right triangles that have a hypotenuse and a side or a leg in common are always going to be congruent, because that third leg is determined by the Pythagorean's theorem. So that HL theorem really does come from the fact that we have a right triangle, and that way we can show that all three pair of sides are congruent. Let's see, example B. So this one's a pretty straightforward one. Again, they've got a pair of legs marked congruent, and then they have the hypotenuse that they share. So this again would be the HL congruence theorem. Real cut and dried on this one. How we've done this in each one of the lessons is we've learned the new theorem, And then we practice it with some triangles that have some given markings and some other things we can tell using things like vertical angles and reflexive property and stuff like that. And then they give us some where they say, what more would we need to know? Like, we might not have enough information right now, but what more would you need to be able to prove these triangles are congruent by the HL theorem? So first of all, looking at A, I know for a fact that these are right triangles. See, I see the right angles. So I've got that part. I also know for a fact that LK is congruent to itself. That's a shared part. And that part happens to be a leg, right? So in order to prove these congruent by HL, which is the one they want me to use, I'd have to prove the hypotenuse of one triangle is congruent to the hypotenuse of the other. And the hypotenuses here highlighted are called LW. So I'd need to know, and again, I don't have enough information for that, but I would need to know that LW was congruent to KJ. Okay? Now, there's no way to tell that without somebody giving me more information, but if I did know that they were congruent somehow, then I could use the HL congruence theorem. Now, looking at B, what more would I need? So again, I'm looking to write down the things that I would need to use HL, right? I mean, there's, depending on whatever theorem is stated here, I would need different things. But if I want to use the HL, they've already shown me that the hypotenuses, however you want to say it, I don't know the official plural of hypotenuses, but we know for sure that they've already marked them congruent here. And then because this is a right angle and it's a vertical angle with this angle on the other side, we know for sure those are congruent. So we don't really need that because it's already a sort of a given. Of course, we would write it in a proof if we were writing a proof, but it's automatic. Vertical angles are always congruent. So what we would actually need would be, we could possibly do two different pairings. We could know these were congruent because then that would be a pair of legs. So we could use the fact that HG was congruent to QG, or instead, if we knew that these were congruent. Okay, so if we knew that PG was congruent to IG, then that would be enough to use HL. So you have some options here on this one. Could have gone with either pair of legs because you just need a pair of legs and the hypotenuse. And we're going to wrap up this nice short lesson with a couple of proofs. So now proofs are really more just basically the same thing we've been doing, except for that now we're just more formal with our explanations, right? So now we actually list out every fact. We don't just say it. We don't just explain it out loud. We list it in a table. We make some statements of fact, like these things are congruent, these things are congruent. We just account for all three parts that we need, and then we give a reason, which the reasons come from our theorem sheets, right? Or from the theorems we've learned, or definitions, or the postulates, or whatever, right? So what we're trying to prove is that these two triangles that make this looks like a rectangle, we want to prove that they're congruent. So here's what's given to us. It is given that P and R are right angles. So they marked them for us. Okay. Now, just because they said they're right angles does not mean that, and although in here I noticed that in the proof they didn't specifically say they're congruent. So I prefer that I would have probably put a step in here that said angle P is congruent to angle R. Whoever wrote this proof did not agree with my theory that you have to make sure you state every single pair of parts in your proof. They kind of assumed because they're right angles they're going to be congruent, but I would have said it right angle congruence theorem. I would have wanted it in my proof there. But you can kind of sort of just assume that right angles are congruent. Okay, and that was given. And they gave us one other fact. They gave us that PS was congruent to QR. Sometimes they'll mark it on there if they give it to you. Sometimes they don't. So maybe you have to do it. And that was the very next statement. So that was given as well. So we are up to two parts, right? We know the right angles are congruent. we know that those two legs are congruent, and the other thing we can tell for sure is that that shared side, SQ, is congruent to itself, and that's reflexive property. Reflexive property, right? And then now if we look at these markings, because if I thinking the S and the A marking like strategy I use, if I call this A and this S and this S, I'd say, ooh, I don't have one of those. I don't have an ASS theorem, or I don't have an SSA theorem. So that I know, oh, okay, that's the HL. Okay? Because technically, this is a right triangle. So it has, instead of just plain sides, it has a hypotenuse and it has two legs. And I happen to know that they have a leg that's the same length in the two triangles, and I know their hypotenuse is shared, so that's the same length. Okay, so here we are at our last proof, our last example of the notes. And this is actually going to be the last of our triangle congruence theorem. So I know we've been spending lots of time on that. So we've learned now a total of really 5 different ways, technically 6 different ways to prove triangles congruent, if you count the showing all 6 parts. But so this is the last of the last. So letter B says given J and L are right angles. So again, in other words, these are right triangles. That's what they're telling us. We've got some right triangles here. And K is the midpoint of JL and MN. So right now what they're doing is they're saying, hey, that thing is the midpoint of both segments that it goes through. So it's the midpoint of this segment, and it's the midpoint of this segment as well. Well, that's great. I got a 2 for 1 then. With just the definition of midpoint, so these two things were given. With just the definition of midpoint, I can prove both of these things, that JK is congruent to LK, and that MK is congruent to NK. And those are both by the definition of midpoint. Okay, because midpoint cuts the segment into 2 equal parts. And then now if we look at these markings, we've got the HL congruence theorem. But now something to think about. Let's say I didn't really notice they're a right triangle, so I have this option of using the HL. Maybe I would have added on another step in my proof, and maybe I would have said, hey, you know what, I could prove those angles right there are congruent using the vertical angle theorem. So I could have used the side angle side theorem. Okay? So this is why if these proofs have like blank tables on them, like they don't give the statements and you provide the reasons or vice versa, you could have done it a different way than, say, somebody else, and you're still equally as correct. So we've just, the more ways we learn to prove things, the more options we have, and the more different kinds of proofs for the same thing we might see.